Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up a custom state machine inside of the Godot game engine. So a state machine allows you to switch between logic states such as ground, air, and landing, and later on you'd want to add extra stuff to like attack, I'm sure. And the idea is that you separate your character's game logic out to individual states to keep it more manageable than stuffing everything in one singular script. So if we take a quick look at the hierarchy of nodes, you'll see that there's an animation tree node, which in a sense contains the transitions between the different animations that can be playing. Now it's important to note in this case that the animations and the character's moving logic are two separate things. So while the animation tree might have a animation state machine as its root node here, that this is actually separate from the logic controlling our character, which is the state machine itself. So the state machine controlling the character is just a script that extends from node, and you'll see that the states that it can switch between are their own scripts down here below. So if you followed my previous tutorial, you could think of it as you're taking all of the logic of the player, and where it makes sense to put it in a separate state, like ground, air, or landing, you separate it out. And then the state machine will pick which set of logic to run at any given time, depending on what's happening to the player, whether it's in the ground or the air, or you press the jump or attack key, that sort of thing. Okay, so now I'm jumping into the start of this tutorial where we have a scene set up, and there's actually already animation logic for our player. In the previous tutorial, I set all of this up using animated Sprite, which is okay for simpler solutions, but you can see that this doesn't really set up the transitions between the different animations. You just have a list of animations and you tell it which animation to play at any given time. However, you'll see if I go ahead and hit play that basically our character works almost exactly the same as before. It's a little less floaty because I did turn the gravity down later on, but you have the same basic controls and everything right here. That was the endpoint of our previous tutorial. But if I jump into the player script, you'll see one of the original problems is that when you cram everything into one script, it can become a little bit unruly. So this tutorial is going to be taking most of the functionality inside of here and putting it inside our state machine. The other thing to note is that animated Sprite 2D is actually incompatible with the animation tree. So in this tutorial, we're mostly going to be taking this already working code and making it a lot more clear and concise, easy to understand. We'll also be switching out from animated Sprite 2D to a standard Sprite node, along with an animation player and an animation tree, because that will give us more long-term flexibility in controlling our animations. As you can see here, with the animated Sprite 2D, it's very easy to change animations, but you really can't set up any direct connections between the animations. Everything has to come down purely to code. Which means that although it's simpler, it's also a little less powerful in controlling your character. And later, when we have a whole bunch more animations, I think that the animation tree will help pay off a little bit. So before I get started, you can get the same starting point for the project in the description. There will be links where you can download them for free. So I would recommend you go ahead and you get that starting point, and then we go from there. So with that done, the first thing we're going to do is add the nodes in for the player, which is necessary for our changes to the animations. So I'm going to right click on player, add child node, and we're going to get a Sprite 2D node and create that. We're also going to need our animation player. So type in animation player, find that node, and then a animation tree. So you have the animation tree. Now, when you have an animation tree, you'll get a warning, which basically says that it needs to know what the animation player is. And you should also have a root node for the animation tree. So let's assign the animation player over here in the inspector. Assign, and you can just choose animation player from the list of nodes. And then for the tree root, I'm going to click here and choose new animation node state machine. So this is where you get your little graph that I may have shown for a second in the reference project. So we're just going to set the same thing up. Now, for us to actually add these animations in, we have to have animations created on the animation player. So I'll switch back to the main project. You click on the animation player, and let's add in some animations. So I'm going to do new here, and I'll type in idle, hit enter. Now this is going to look very different from what you would see on the animated Sprite node. And even if they have the same name here, these are separate animations, and you don't use the idle from the animated Sprite. You actually create the animation inside of here by adding tracks and keyframes for your Sprite node. So we can go ahead and do that now and basically create the equivalent of the idle from the animated sprite on the 2D sprite node. So in AnimationPlayer, let's add a track, property track, select the Sprite 2D node as the node that we're trying to animate the property for, hit OK, choose texture, hit open. Now do that 2 more times. Let's do add track, property track, Sprite 2D, and choose H frames. So this is the number of columns in the sprite sheet. If you have, let's say, 6 frames and each frame has their own column, then you would want to separate it to 6 H frames or 6 columns. So let's hit open, and we'll put that number in a minute. Add track, property track, go to Sprite 2D, OK, and let's choose frame. So this is the actual number of the frame that we're showing. So choose open. And now to get a quick reference of what values we should have here, let's take a quick look at the animated sprite again. So here we can see that our idle animation has 4 frames. So that's a pretty good indicator that we're going to separate into 4 H frames, and we want to play frame 0, 1, 2, and 3 in a sequence. So in AnimationPlayer, let's add the texture in, which is the PNG where the frames are contained. So I'll insert a key and then move it to the 0 position at the track. For the value, we can go into Art, Legacy Fantasy, which is the art pack that we downloaded for free in the first video. Let's go into Character and then Idle. And then you want to take Idle Sheet and drag this to the inspector over here and let go there. So now what this means is that when this animation starts at the very start of the animation, we're changing the Sprite 2D's texture property to be this image. So we need that to be set so that we can play those frames of animation on our Sprite 2D node. So for H frames, we can easily see that there's 4 columns here and 1 row. So we just need to set H frames to 4. So I'm going to right click, insert key, move the position to the start, and then the value to 4. So for frame, we just need to in sequence play frame 0, 1, 2, and 3. So the best way to actually keyframe this out is to go to Sprite 2D, look for animation, and make sure you have the animation window open for this so that these keyframes show up here. Go to the start at frame 0 and make sure your snap is set to the speed you want the animations to play at. For this video, everything's going to snap to 0.1 seconds, so we don't need to worry about that. And then click on the little plus keyframe icon next to frame 0. Click that once, and you're going to get frame 0 to play at timing 0 seconds. And it's immediately going to jump to the next snap position, which you can see here is 0.1 seconds. So every 0.1 second, we are switching the frames. So you'll see that frame in the inspector is auto-incremented to 1. So if you click add keyframe again, then now that's going to add the frame 1 at seconds 0.1. And then frame 2 will play at seconds 0.2 seconds. And then frame 3 at the next interval. Okay, so let's zoom in on our animation graph here. And you'll see at the top here that the animation is much longer than our frames are actually playing for. So what you want to do is change the length of our animation over here on the right to 0.4 to match the number of frames here and enable looping. So now we can hit play here and it's actually going to loop the animation for our player. So pretty much the exact same thing with animated sprite over here. You can see it kind of playing in the background. I have to hide the Sprite 2D node for that. So let's show the animation here from the original animated sprite, and that's playing there. Hide the animated sprite, show the Sprite 2D, and let's go to AnimationPlayer, hit play, and you can see that functionally speaking, they're the same. This has a couple extra steps, but the reason why you would do AnimationPlayer is so that you can use it in the animation tree. So we'll come back to this in a second, but this will set up the animation graph for which animations connect to which other animations. So in AnimationPlayer, let's create the run animation. So animation, new, and then run. And we need basically the same 3 track properties. So add in Sprite 2D texture, add in property track Sprite 2D H frames, and add in property track Sprite 2D frame. So we essentially repeat the same steps. Let's add in the texture keyframe. You can right click on the graph and hit insert key. Let's find the run sheet in our assets. So run sheet, drag that to the value here. And this is going to be 8 keyframes. So we want to right click insert key on H frames, set this to 8. And then we just keyframe at the right timing. So before that, I'm going to change the timing to 0.8. I'm going to enable looping. Now let's go to Sprite 2D and let's hit add keyframe for the frame 8 times. So 1, 2, 3, 4, 5, 6, 7. Oh wait, hold on. Undo a couple times. I'm going to move the animation position to the start here so that it actually switches the texture. It didn't do that the first time. So let's do the keyframing again. 0, 1, 2, 3, 4, 5, 6, 7. Basically do it until the last one is value 7. So the first one should be 0, the last one should be 7, and it should play in a sequence. And to test it, just hit play. And then we have our run animation. So you could see right there why we actually had to keyframe the texture changing as well. Until the animation is actually playing, the texture hasn't changed in the Sprite 2D node, and then it would be playing the wrong frames. Even if the animation is called run, it still has to change the texture basically. Okay, now at this point we have 2 animations, so we can make some use out of the animation tree. I'm going to click on animation tree, and on this graph I want to right click and do add blend space 1D. So a blend space allows you to move between different animations or blend between them depending on a input value. So this input value is going to be our X movement, left or right or neutral. If it's basically at neutral 0, otherwise the player has no input, then we want to play the idle animation. But if we're trying to move left or right, then we want to play the run animation. So add a blend space 1D. I can just rename this to be move. And for this kind of node, we can edit it, jump into it by clicking on the pencil sign. And here we'll see our little graph. So it's 1 dimension, which means there's only one value that's going to be changing here. At the center, as I mentioned, I want to play the idle animation. So click over here in the top left for create points, then click roughly at the center of 0, go to add animation idle, and then click on the far right and do add animation run. And on the far left as well, click over here, add animation run. So for the blend value, if our value is 0, it's going to play idle, but if it's plus or -1, it's going to play the run animation. Now, by default, it's actually going to try to blend between your animations, which doesn't make much sense for pixel art. So click here, and we're not going to blend between the values in our animations, so to speak, but we're actually going to choose the second option here. I think it might be called discrete or something, but what it means is we're 100% in one animation or the other. So if our input value is close to 1, it's going to just be playing that animation. And if it's close to 0, it's going to be playing this animation, and that's it. So make sure the blend is the second option, not the first one. So next we want to create a path between start and move so that when our animation tree starts in the scene, it'll automatically play the move 1D blend space. So click the third option in the top left, connect nodes, click on the start node, hold it, and then drag to the move node. And by default, this will automatically play. It'll automatically make the transition between start and move, which is fine. So what about the blend value inside of the move blend space? How do we actually set that? Well, once we have our blend space defined by creating this node here, we can click on animation tree, and there'll be on the inspector a tab called parameters. So click on that, expand move, which is our 1D blend space, and you'll see that there's this blend position property. If you hover over it, you'll see that the path to that property is parameters/move/blend position. So somewhere in our script, and we'll do this in the player script, that we just set the blend position to whatever we want it to be. And I'm going to be defining that based on our movement input, which is actually already set up. So this should be pretty straightforward. So in order to get this path, I'm going to right click on blend position, and let's copy the property path. I think that's what we want. So now we want to jump into the player script, and we'll get a reference to the animation tree so that we can set this parameter. So open up the script player.gd, and then up here at the top, we'll do @onReady var animation_tree, colon is type of animation tree, equals $animation tree, which is grabbing the node from our list of nodes in the scene being our player. So we'll have this ready and accessible to use at the start of our script. One thing you'll see as an error most likely when you look at your animation tree is that it will say it's inactive, and that if it's inactive, basically it can't play these animations. So to make sure that when we start our game that the animation tree is actually running, I'll add another function right above physics process here. This will be function underscore ready. So we'll add that in, and then we do animation underscore tree dot active equals true. So this means that whatever settings we have outside the game, when we start the game, it's going to start playing the animations from the animation tree. It's not required to do it this way. You could just click on animation tree and check active all the time. But then that means that the animation tree is going to be running and using its logic to switch between animations over here. But you might actually just be testing your animations in the animation player. So I don't actually like to have the animation tree mess with that while I'm still editing my animations. Hence why I'm doing this, where we just set it to active at the start of the game. Okay, the next thing we need to do is set that blend position property. So in the previous video, I created a function down here called update animation. It's just something that I run every update for physics process. So if there's 60 physics process updates, then that's 60 times a second. Let's come down to update animation, and I'm going to do animation underscore tree dot set, and then we give it a property we want to set. You'll see that Godot is smart enough to know that there are parameters that we can set here. So we can just click parameters move blend position here. Or if you were copy pasting, you can add the quotes and then do a control V to paste it in. Same thing basically. And we need to give it a value. So the value here is something between -1 and 1, 0 inclusive. So that's going to be our directional import, which I was storing as a vector and a variable called direction up here. So all we need to do is direction.x and hit Control S to save that. Now, as you can see, a lot of the logic previously was about using the animated sprite. So I'll try to hit play and see if it'll work so we can see this move animation play. But we might actually have to remove the animated sprite references first. Let's hit play and give it a shot. Okay, so we have our character. I'm going to move him. Okay, actually, that is working as intended. The only thing not happening right now is that the character's not flipping a sprite, and that's because the logic for that was setting it on the animated sprite, not the sprite 2D. So that's one way we know we're actually looking at this sprite 2D and not the animated sprite here. So far so good. We're switching between two animations just by having that import logic added to the animation tree. So let's go back to the player script and let's go down to update facing direction. We want this to now change the direction on the sprite 2D, not the animated sprite. So I'm going to rename the reference from animated sprite to just sprite. And let's Control V, paste that down here. And you'll see that the identifier is not in the scope because we haven't written it at the top. So let's go up to the top to fix that. For right now, I'm actually going to hide the animation tree window so you can see the script better. And let's jump up here. So at the top, we have animated sprite. So same idea, except now we're getting a sprite 2D, and we're going to get the $ sprite 2D. Now, by writing this and then changing the variable name here, it's going to break a lot of stuff in the script because all of the logic for controlling the animated sprite was right inside of the script. So let's go ahead and work at that. So down here, I was checking the animation on the animated sprite, whether it was jump end, to control whether the character could move or not. When we get around to our state machine, we're actually going to give each state the ability to set whether it can move while in that state or not, just with a simple Boolean checkbox. So for right now, I'm going to remove this completely, and we'll just leave it as if the directional import is not 0, then we'll move. Okay, then we can come down here to the animations. The animations, once again, we're going to be controlling that through our state machine. So all of this right here, you can either get rid of or comment it out for now. So for right now, I'll just get rid of all of this. And then down here for the jump function, playing the animations. Once again, that's going to be a function of the state machine, not of the main player script. So for right now, I'll comment these out so that we remember that we're trying to do that when we do a jump or a double jump, but how we'll do it later is differently. So any reference to animated sprite, basically, I'm going to either comment out or get rid of completely. And on sprite animation finished here, I guess we can comment it for right now. That's fine. So with all of that, we can hit Control S, and there should be no more reference to that in this script. If we run the game one more time, then we'll still be able to move our sprite 2D because this motion is being controlled by the animation tree. But everything else, we basically need to create more animations, and we need to set up our state machine. Okay, so to create our state machine, right-click on Player, add a child node, and we're just going to search for a standard node. So the base class for all scene objects, we're going to create that. And I am going to rename this node to be, let's say, character state machine. Now let's add a script to it. Right click, attach script, and we will create a brand new script here. So character state machine.gd. And I'll go ahead and create that. So at the top, as an identifier for the script, I'll write class name, character state machine. This part is kind of optional for now. But when you specify a class name for a script, then if you look at, let's say, a node, then you can identify that the node is specifically a character state machine and not just a generic node. So using class names is one way that you can be sure that when you're dealing with a node or a resource, that it's the right type of node or resource. So for instance, we might have a list of states. So I'm going to create a new variable, states, and this is going to be an array of state. So right now we get an error where state is not actually available in the current scope because that's something we need to set up. So in the file system, I'm going to go down to character and I'm going to create a new class here. So I'm going to right click on character and do new script. And let's call this state.gd. It's going to inherit from node up here. So create that, then double click on state.gd and let's give it class name state. Now that that's there, if we go back to our character state machine and try to save this again, then the error should go away because now it knows what it's talking about. So we have an array of a type of object that is state, which inherits from node. And this is the variable where we're going to be keeping track of all the states below our state machine. So the state.gd script is going to be kind of a abstract template for what we actually build upon, because each different state is going to have its own logic. So we're going to need to write different scripts which inherit from state.gd for the list of states below our character machine. But this will be the base class. It'll kind of set things up, what every state should have. And anything that extends from state will be recognized as a state that we can use in the character state machine. So let's create our states. I'm going to right click on character state machine, add child node, and let's add in a new node. So I'm going to rename this to be the ground. So for this ground node, I want to create its ground state. So let's create this script over in the inspector. We can take the empty script slot, do new script. And for inherits up here, I want to type in state. And then for the script name, I will call it ground state to be a little bit more specific than just ground, making sure that we're dealing with a state of the character. So let's create this script here. And if you want, you can give it a class name as well. Probably not needed, but it certainly doesn't hurt to give it a class name ground state. So I'll type that in. And let's create our other states as well. So I'm going to right click on character state machine, add child node, create the node. I'm going to rename it to be air. Let's create the script for it over here on the right, new script, and then we'll call it air state. Inherits from state, create. We'll give it the class name air state. Okay, and one more. Let's right click on character state machine, add child node, node, rename the node to be landing. Let's go over to new script and then inherits from state, but we're going to call it landing state.gd. Create. So right now our state machine does not know about the states which are contained under it. One way would be to add a @export for your state array variable, and then you can click on state machine and assign the states here. But then you have to do it manually, and if you ever add another state, then you need to be sure that you add it to this array here. It's not a bad option. But another way would be to write a function where when your script starts, it'll automatically grab all of the states that are contained under it. So we can do a function ready. Since this is a node, it contains all of the functions that a standard node in Godot would have. So we want to get the children and check if any of them are a state. And if they are a state, we add it to our array of states. So let's do a for child in get children. Basically, grabbing all of the child nodes, and then for each child, we can check if it is a state. So we'll do if child is state, then we can add it to the states array. So states.append, and we're going to do child. So else, if it is not a state, then that's probably not actually desirable. It probably means that we have a node under here, which shouldn't be there. So I'm going to add a else And then we're going to print a warning, or actually it's a push warning, I think. Push warning. And the warning message we'll say is that child, and I'll do plus child.name is not a state for character state machine, or something like that. Just a indication that when we're debugging our game, we can see that we messed up somewhere and that one of these is not actually a state. So later you'll see that for these states, we may need the states to know about certain things in our player scene, such as the animation tree, or maybe the character body 2D, the root node, in order to do things like move the player, add jump velocity, that sort of thing. So I'll set a little note here that will set the states up with what they need to function. After we acquire the states and verify that they are a state, we can just set them up on our state machines on ready function. So let's make our states useful. One piece of information that we would want to know for our states is whether we can move in that state or whether we can't. So if we click on state.gd, we can set up a Boolean variable here. I'll do a @export var, and we'll say can move. And this is a type Boolean, and we can default this to true. I think more often than not, we would want a state to be able to move than not be able to move. So your default value can be whatever you want. So with this added in, we should have a can move variable, which we can set on each of the states. So you should be able to see it in the inspector up here, but you may need to re-add in the script for your different states to get that to pop up. So if we click on air state here, you can see it's missing. So just drag air state over here again. So you can just reset it by removing the script and adding it back in, get that to pop up. So there we have it there. And on landing, we also want the same thing. Not sure why it bugs like that there, but you definitely should be able to see the state Boolean. So actually on landing, that's the one where we don't want it to be able to move. So turn off can moving here. But on air and ground states, we want to allow the character to move. Specifically, we're talking about left-right movement. So we want to be able to do that in the air and the ground. And we can specify for each state whether we want that or not with the can move variable. So we need to look at this in the player script or wherever we have the logic controlling our character's movement. But we actually need to know what state our state machine is in first. So if we click on state machine, we should probably set up what our default state is going to be. And then it can automatically switch between them as we need it to be. So inside of the character state machine script, we'll add a @export var. We'll say this is current state, and it's of course this type of state. Hit Control S, and you'll be able to assign the current state in the inspectors. So let's assign that to ground by default. And now we have the current state at the start of our state machine. Of course, there's no logic to switch between the other states, but we can at least check this for right now. Now, in order to access the can move inside of the state, we could just do state machine.currentState.canMove, but we might prefer to write a little function here to check if it can move. Check if can move, and then we'll just return current state.canMove. It just makes it a little bit more concise when we check it in the player script. So I'll copy this function name. Let's go to player, and we'll scroll down to where we had the direction x is not equal to 0, and therefore we can move the player. And we'll add our extra condition. So we'll do and we'll say state machine dot the name of the function, and we'll just check that. So this is returning a Boolean. If the Boolean's not true, then we can't move, and we're not going to move. We're going to do this instead. Now, of course, as usual, we need to reference the state machine in our player script. So let's go up to the top and do @onReady var character state machine. And this is a character state machine type. Since we did create that class name, we can do that. And we'll set that equal to $ character state machine. And actually, I'll get rid of the character part here. It's kind of implied because we're in a character body 2D. So with that, as long as the variable matches, then this should go away. It should be able to work. So let's click on ground, and we'll verify that can move is checked. Let's hit play and test it out. So if we move left and right, we can test and see that we can still move. And for right now, I'll toggle can move off. Let's go back and take a look here. And you can see all of a sudden with can move off, our character can't move at all. The animations still play, of course, because the animation logic is separate from the movement logic. But we have stopped our character from being able to move. Okay, so I'm going to revert can move to true since our character should be able to move. let's go ahead and work on our next logic, which is being able to jump while inside of the ground state. So if we hit play, we can jump right now, but I don't want that logic to be straight within player. So let's go to player, and I'm going to take this jump bit here, specifically the velocity y equals jump velocity, and I'm going to control X to cut that. Let's remove the jump function entirely. And where we have jump up here, I'm going to comment that out, and we're just going to put pass for right now. Pass means you just skip over it and you don't do anything. And let's go into the ground. I'm going to do a comment, and then I'll control V to paste in that velocity y equals jump velocity. So if we want this to work, then our state needs to know about the character body so that it can change its velocity in some way. So if we want to be able to do this somewhere within the script, then we need to know about the character body, because that's where our physics body is. So let's go to character state machine, and let's add in another export var. And this is going to be character, which is a type of character body 2D. And we'll manually assign that in the script. So when you do the $ thing, I believe that this only looks for child nodes, not parent nodes. So a better way of getting the parent node, the character body 2D, might be to have it export as a variable, and then you could just click on assign and then choose player from the list of nodes right there. Okay, now that we have that player node, we can just tell each of the state nodes about that same character so that they can use it when we're doing our state logic. So I'll do states.character equals character. Okay, now of course there is no property character for a state. So let's create that property in the state script. So state, and we'll have var character of a type character body 2D. And I'll just have that added in there. And that's basically it. Oh, and we're not changing it on the array of states. We're actually changing the character of the child state. So child.character equals character. And then you just need to make sure that in state, there is a variable called character so we can set it. Okay, so the other thing we're going to need for our state is the ability to respond to player input. But we only want to be responding to input when we're actually in the state, which is selected as our current state. So rather than just doing something like function underscore input, which we could technically do because it is still a node, but then that would run all the time, is I'll create a similar function, but something that will call only from the state machine. And this will be function state input, and we'll take the event, the same event that we would get from function input from a node. So for right now, we'll pass this. And I'm also going to basically copy paste this over to state so that we know that a state can have the state input function. This will be the default if we don't override it with a child class. So basically, if we never set up state import in ground state, then it's just going to do the state import of the state class, which is to say it's going to do nothing. So let's go to ground state and let's set up the state input. I believe we can also specify that we expect the event to be of a type input event. So when you specify it, it'll give you helpers for saying what you can do with an object of this type. So I'll just copy paste that into state as well. So event of type input event. Okay, so in ground state, let's check if event.is pressed. So you can see it's working there now, or is action pressed actually. So we want the action for jump. So we set that up already. I'll choose the jump action. So if that's pressed, then we'll do something else right here. If for some reason you don't see the jump event on your list, you can go to project settings, input map, and you can see your custom events, which are defined here. And you can add new actions in here and tie them to a certain key. So when we have the jump pressed, we want to make our character jump. So we could just, add in the jump function again. Function jump. So the first thing we're going to do here is to set the velocity y equal to the jump velocity. So I'll remove that comment and move that down there. But we're not setting the state's velocity. We're doing the character.velocity.y. So that should be our character body reference. And of course, the jump velocity is something that is still stored in the player, but we can move that to the ground script. So let's go to player, up to the top. I'm going to grab this jump velocity export, just control X and move it into ground state. Let's control V, paste this in. And now basically each of our states, we're defining their own parameters for how the character should act here. So you might have a double jump in the air, which is a separate velocity float than the jump on the ground. Maybe you can also do a wall jump. So you can define different jump velocities for each of those different states like this. And if we click on ground, you can see the jump velocity default there of negative 150. We're going to use that to apply to the character's velocity here. Now, when we jump, we're also entering the air. So we want to switch to the air state. So to do that, let's have a variable that each state has for the next state. When we're ready to move on to a new state, the state machine can pick up on what state we want to move on to and make the switch. So let's go to state, and we'll have our variable. So variable next state is of type state. It's going to be null by default. And then in ground, we want to take the next state, and we want to assign that to the air state. Now, what does the air state mean in this case? Well, I think the easiest way to be specific is to have a export variable, which references this air state down here. So let's add that up at the top at export var air state, and this will be of type state. And we'll take air state and set the next state equal to that. Now, if we click on ground, you can assign the air state from the list of states. So I'm going to choose air. And now for this state, the next state is set to air state, which means in the state machine, we need to actually make the change. So let's go to the state machine. So because this is a node, we can make a process function where it's running all the time and checking for certain things, like if the current state has a next state set. So let's do function underscore physics process, and we'll check if the current state next state is not null. And if that's the case, we're going to switch states. And we can say current state dot next state here, because we already know which state we're trying to move into. So let's create that switch states function switch states. So when we switch states, we want to set the current state to the new state. First off, let's get that state as a parameter. So new state, new underscore state is of type state. And we'll set the current state equal to the new state. So this would kind of work already. In that if we switch to a state that can move off, then the player wouldn't be able to move anymore, which is good. But we can actually add extra things to our states. So for instance, we might want to do certain things when we enter or leave a state. So we can set that up here with something like if current state is not null, then we can do current state dot OnEnter, basically calling whatever logic we need it to do when a state enters. And we can also take the current state and remove its next state. So current state dot next state equals null. So this will make sure that when we re-enter an old state, that the next state is cleared, so that it's not going to immediately try to switch again when we're in that state until we have that logic, which determines that we're switching to a new state. So that can be what happens before we enter the state. Oh, sorry, this should be on exit. On exit for the current state. And then down here, we're going to do current state dot OnEnter. So this will work because we've already switched the current state to the new state. Now there's no OnExit and there's no OnEnter in our state class. So let's click on state and let's write those. So function OnEnter, by default, we'll just pass, and then function OnExit, and we'll just pass. So this is just if we need to do extra stuff, then we can do that. Okay, now lastly, for the ground state, for right now at least, our state import function that we wrote, it exists in the ground state. It exists in the state.gd, but I don't think we've called it anywhere in state machine yet. So just like with a normal node, we can do input and then check for the input event, but we only want the ground state to be doing that, once again, when it's actually the current state. So what we can just do is whenever the state machine gets access to the input events, we just pass that along to the current state that's active in the machine. So down here, we'll do function underscore input event of type input event, and we'll do current state dot state input, and then we'll pass the input event. And that's all we need to do here. So when our state machine is running and there's a current state set, it's going to be calling the state input. But when that's not the current state, that state is not going to be running its state input. So basically, we won't be able to jump unless the current state is the ground state. Okay, let's clear the error messages, save it one more time, and let's go ahead and hit play. Let's see if we can get a jump to occur. So if I hit space, Okay, there we have our jump. And as you can see, I can't hit space again because we had no way of exiting the air state to the ground state. And right now you can kind of see that it's a little unclear what state we're actually in, logically speaking. We see what animation is playing, which is run and move and idle, but we don't see that we're in the air state, logically speaking. So to make sure that we know, let's add in a debug label that will just hover above our player and will make it really easy to see what's going on internally for the player. So I'm going to right click on player. Let's add a child node. I'm going to type label. So create the label, and I will rename this to be state debug label or something like that. For the text, let's just default it to be state : Let's go to 2D view and let's move this above our player somewhere around there. Let's add a little extra room so we can add the text for the state that the state machine is currently in. And let's add a script to the label, which will grab the current state from the state machine. So right click on the debug label. Let's do attach script. Okay, we can just keep it state debug label.gd. That's fine. And we want to have reference to the state machine. So let's do it with the export variable at export var character state machine, or just state machine actually. State machine : character state machine. And what we'll do on process is that we'll set the text of this label to whatever the name of the current state is. So text equals, let's see, state as a string plus state machine dot current state dot name. And we can remove the bit about the ready function. Click on state debug label, and let's assign the state machine to the character state machine in the scene. And that is probably all we need there. So let's hit play. And now we can see state ground. If I hit space, we enter the air state, but we never leave the air state. So already we can see that that debug label can be pretty handy. It's not something you would show during the production gameplay, of course, but this kind of thing is helpful for testing. Okay, so let's hit close and figure out what's going on. So what's going on is that our air state basically does nothing yet. So we need some logic to determine when we should set the next state equal to the ground state and from within the air state. Let's add in add export var, and let's say ground state of type state. Okay, so let's click on air and assign the ground state just being ground over here. Since we did create the class names, you could be more specific and say it has to be a ground state. I think that's a little overly restrictive here, so we're just assuming that you know which state to assign. Okay, so next we need to check while we're in the air state if we have touched the ground. So we would need something of a process function. So I'm going to create a function and call it state process because I only want this to run while it is the current state. So we'll do this just like a normal process function, function state process, take a delta, and we'll check if the character dot is on the floor. So if the character is on the floor, then that means, well, floor equals ground, so we can set the next state equal to the ground state. So now we need to take this bit and move it into state. So let's add in our template function here. Control V, paste it in. We'll do a pass. So state process, we want to run this whenever the state machine is processing. We also want the current state to process. So in state machine, let's find where we have our physics process, and let's do current state dot state process, and we'll pass in the delta. Okay, cool. So now this is only going to run when we're actually in the air state, and I think that might be all we need to switch back to ground. So let's hit play, and I'll hit space. We go into the air, and we land on the ground, and that's basically it. So hopefully after the initial complexity of starting to set up the state machine, you can kind of get the feel that each of the individual states become quite simple when their logic is pulled out from the original player class. So in the air state, we'd want to be able to do a double jump as well. So let's pull out that logic from player, and we have a double jump velocity. I'll just control X, go to air state, and then let's paste that in as a export variable. Back in the player, of course, we needed that double jump velocity before. So let's just take the double jump function and control X and move this into the air state. So I'll just kind of paste that in there. We're not doing animation lock anymore because we just have the can move variable for a state, so we can get rid of that entirely. And we'll still have the has double jumped variable. So we only want to be able to let our player double jump once, at least by default. I mean, some games have a triple jump, but let's create a variable has double jumped, and let's set that to false up here. So when we double jump, that's going to be true. And when we do that, we want to take the character.velocity and set that equal to the double jump velocity. One more thing we're going to need to do is to check when we exit the state that we churn has double jumped to false. But we actually only want to do this if the next state is the ground. So let's do function OnExit, which we already set up before. So the state machine should be running this. And we're going to do if next state equals ground state, then we're going to set has double jumped to false. So that resets our double jump. This is just kind of necessary because you might have like an air attack, which would return you to the air state. But if you never touched the ground, then you still want the double jump to be tracked. Otherwise, you'd be able to attack and then do another jump, and that would get kind of messy. Okay, and of course, we need to actually call our double jump. So let's do function state input, and we take the event of type input event, and if event dot is action pressed, and we're looking for the jump action, then we're going to double jump. Oh, but also the other condition there is, of course, that has double jumped is still false. So and not has double jumped. Okay, so that's what it should look like. To have two conditions for the logic, you do two ampersands. To reverse the has double jumped boolean, you use exclamation mark as not. I think you could also type it like this, literally the word not, but I'm used to doing it this way. So both will work. And that might be about it for the air state. So let's hit play and let's test our double jump. Okay, yeah, so we get an error in the player class because double jump is no longer a function here. So this whole jump logic, it's already been moved to the ground and air states. So let's stop the game for a second, and then let's just select all of this and delete it. So already you can see that our player class is getting pretty thin, though all the logic is technically still there in the state machine. So let's hit play. Let's move around. I'm going to jump once. Okay, that's our normal jump. Let's do a double jump. So space and then space. Did not work. Let's figure out what went wrong. So it looks like I did not actually make that into a function call. So remember your parentheses. Let's save that, hit play, and test again. So space for one jump, two space for double jump. Okay, you can kind of see that there. So one jump, two jump. The second jump is less because the double jump velocity is set to less, but it is still working there. So something I actually did in the reference for the state machine project is I took the gravity down by half again. So I'll go to project settings, and let's actually do that again. So if you search in general settings for gravity, you can find the setting here. And I'm just going to literally take this 490 and divide it by 2 again, which gives 245. So if we close that and hit play, we should have a very floaty character now. So one jump and then two jumps. And that can kind of make it easier to see the double jump going on there. That gravity might be too little, but let's add the animations back in for the jumps before we mess with that again. So let's go to 2D and let's do AnimationPlayer. So back to setting up animations, let's create a new animation here. So I'm going to call this jump start. And so let's add a track property track, Sprite 2D texture, add track property track, Sprite 2D, H frames, add track property track, Sprite 2D frame. Okay, and then let's insert the key. We want the jump animation here. So in character jump all, I can just drag the all sheet here, which is 15 frames because I counted. Insert the key for H frames, set that to 15, not 158, 15. And to see how many frames there are, let's check the reference project. So in jump start, I went to 11. So that's the first 12 frames, right? Okay, so let's keyframe the first 12 frames in here. And let's set the duration to 1.2 as well. Non-looping for this animation. So move the cursor to 0 and then do plus at the keyframe for frame and do that 12 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then we hit play, and that's our jump animation. So this particular character didn't have a aerial jump loop. So I'm just going to, this time, leave the jump animation at this frame until the character starts landing. So there won't be a jump looping animation. We will create the double jump and the jump end. So let's create jump end first. New animation, jump end. And I'll add the property track once again. Texture, H frames, and the frame. So, you know, this gets pretty repetitive, of course. Let's right click, insert, and let's, well, it should be that, yeah. Just to make sure, I'll drag in the jump all sheet and insert the key, 15, and we want the frames from 12 to the end. So this is 15 frames, so that means 12, 13, and 14 are going to be the animation frames for our landing sequence. So Sprite 2D here, increment to 12. Okay, and now I'm going to hit add keyframe, add keyframe, add keyframe. So this should be a 0.3 duration. I'll hit play to test. It's very quick, but that should be all we need for our landing. I'm just calling it jump end because that's what it was called in the character pack. Otherwise, they might call it something else like landing. But let's also add in the double jump. So the double jump is going to basically be the jump start, but we're going to move from frame 2 to 11, not these first 2 frames, because that implies being on the ground, definitely. So let's do new, and I'll call this double jump. Let's add in the property tracks. So Sprite 2D, texture, property track, Sprite 2D, H frames, and then frame. So texture is still the jump, H frames is still 15, and we want to reset to 2 at the start here. So kind of already in the air, jumping a little bit. Let's add in frames. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, hold on. Maybe we want 10. Okay, one more. I'll insert a key, and this should be 11. So let's hit play. Yep, and that's not going to loop as well. So the duration, 1 second, non-looping. Okay, and I think that's all the animations we need for the video. Let's go to AnimationTree and set the rest of this up. Okay, so I'm going to right-click, add animation, jump start. So jump start is going to come out of move. So I'm going to create a transition between move and jump start. Now, you can actually control your animation tree just by using advanced conditions. So you set a property like a parameter Boolean value on the animation tree directly, and you let the animation tree handle the logic. But actually, in this case, I think it's a little bit easier if we just have the advanced logic be controlled straight from within our character states, the logic states, that is, ground, air, and landing. So for the advanced, I'm going to change that to enabled, which means that we have to call travel on the state machine's playback variable in order to move between move and jump start. So we'll get to that in a minute. Let's add in the other animations. So after jump start, we have jump end. So let's make the connection between jump start and jump end. This will also be enabled, but not automatic. And then from jump end, this means that we're on the ground, so we can go to move. And this one, I think I might have had it automatic. Let me check. Yeah, I did have it automatic at the end of the animation. So if you want a animation to automatically move to a different one, you can change the mode to auto and then the switch to at end. So this means I don't need to tell the state machine to move to the move state. It's just automatically going to do that, because after landing, we're now in the move animation, which we should be. So this is okay. You could still manually call travel to move if you need to, but we'll just, use this for right now because that's what I had before. Now, lastly, we have the double jump animation. So let's add in one more animation, double jump. And where can we double jump from? Well, that is jump start. So let's connect jump start to double jump. And for the advanced, we'll make that enabled, but not automatic. And then we'll go double jump to jump end, which also will be enabled, but not automatic. So that's basically our animation tree set up here for right now. And we just need to take these connections and have them advance within our scripting logic. So in our state machine, when we're setting up the states, we just want to give it access to the playback from the animation tree. So we haven't got to the animation tree in here. So let's add in one more export var. At export var, animation tree is of type animation tree. Control S, and then we can click on state machine and assign it to, of course, the animation tree in our scene. And then when we're getting all of our states, just like before where we set the character body 2D, we can do child.playback, and we'll set that equal to, I'm going to just Control V paste this in here, AnimationTree, and then in parentheses, the parameters of the playback. So when we get this playback variable, we can call .travel on it in order to move between the animation states. So if we jump, then we just tell it travel to jump start, and then it's going to play the jump animation. And if we're in the air and we do double jump, we just say travel to double jump, and it's going to play the double jump animation. And it's basically as simple as that. So I believe we have not added the playback variable to state.gd. So I'll go into here and let's do variable playback. And the type of variable here is actually animation node state machine playback. So this is what you would use when you want to call .travel on a animation tree. So once we have that, we can go to a state like ground. And when we do jump, we can do playback.travel to the name of the state we want to move into. So we could hard type this in, something like jump start, and that would work. But there may be cases where the names of our travel animations don't actually match up what we hard code in here. So just to give the script a little bit more flexibility, I'm going to add at export var, let's say jump animation of a type string. I'll default that to jump start here, or maybe I would actually call it jump since that's a little bit less specific. And then I'll take this variable and move it down here to the travel and paste that in. So now to set the correct name of the jump animation, we just click on the ground state and we want to match the animation name. Not what you see in the animation node here, the jump start, that's just the name of the node, but actually the name of the animation from the animation player list. So jump underscore start. So we click on our ground state and let's go to the jump animation and type in jump start. Okay, let's test if this works so far. So let's hit play and let's try jumping. So we jump and we see that our jump animation plays. So now let's jump into the script for air state, and on our double jump, we're going to basically do the same thing. So remember we were previously doing animated sprite.play and then the name of the animation. This is similar. So we do playback.travel and then we do the double jump animation. Let's make that variable up at the top. So just take this variable name and let's go up to the top and we'll create another export variable for that at export var, paste in the name double jump animation, give it the type string, and we'll give it a default name here of double jump, which I think is the actual one. Click on air and we can see our string name here, double jump. Just make sure that matches the animation name and you should be good. So when we do our double jump, we should play that animation. So let's test that out as well. We go into the air, first jump, double jump. Okay, our double jump is working. Okay, lastly for this video, I think we just need to get the logic for switching to the landing state. So in air right now, when the character's on the floor, we say that the next state is the ground state, but that's actually not correct. We should be doing the landing state. So let's do landing state, and then the next state equals landing state. On exit, if the next state is landing state, then basically just replacing the variable name there. And we're going to assign the landing state to be landing. So our landing state doesn't really do anything except prevent us from being able to move our character left and right. But we still need to give it a way to actually exit the landing state. So the way we can do that is by looking at our animation tree, going to node, and there is this signal callback called animation finished. So we can check if the animation finished is the name of the landing animation. And if that's the case, then we can just set the next state to be whatever should come after landing, which should be the ground state. So double click on animation finished in the node tab, and then select the landing state to connect this to. When you double click that, it'll have the function on animation tree animation finished with animation name. So when this happens, animation finished playing. So we want to check if that animation is the right animation. So let's add an export var at the top. So at export var, and we'll say landing animation name here, and that'll be a string. I'll default this to, let's say, landing, and we're going to check if the animation name equals the landing animation name. If that's the case, then next state equals the ground state, which is another export var at the top. At export var ground state is of type state, and we'll set that up in the inspector parameters. So the ground state is, of course, ground state here. And let's check the name of the animation and just make sure that matches whatever is in our animation player. So we have jump end here. Let's take landing and change it to jump end as the animation name. So setting the right landing animation name here. Okay, let's hit play and test. So if we jump into air, we can hit the ground, we get to the landing state. It does not exit the landing state. So if we set up a couple breakpoints, clicking over here to the left on the script and hit play, and we go through the steps, we can get to the landing, and we can see that the animation that is finishing here is jump start. It's not actually jump end. So what this basically means is that we haven't even moved into the landing animation yet. So in air, we do switch to the landing state, but I haven't actually traveled to that animation yet. So we should do playback.travel to landing animation. I'll go up here and let's add the export var landing animation of string, and then this will default to landing, but I know that that is, of course, actually jump end as the animation name. So I'll set that up in the inspector. Okay, and then that should mean that we'll end up in the right state. So let's hit play and let's see what happens this time. So we jump, and this time we are at jump start, so we shouldn't exit here yet. I'll remove that breakpoint and let's hit F12. Okay, we don't need a breakpoint there. Hit F12. Okay, and this time you can see jump end actually happens, so that's matching, and we should be able to exit the landing state. Okay, because it keeps switching to the code, you can't see what's happening in the game, so I'll show it again. Let's hit space, and we're in the air, we get to the landing, and then we switch back to ground. So we jump, we hit the ground landing, and then we switch back to ground state, since the right animation matched here. One last fix: when the game starts, even though our character's in the air, you can see that the state stays ground. So we do need to have a check where if we're on the ground and then somehow we end up in the air, maybe by falling off a cliff, that we actually go to the air state, not just staying in the ground state. So in ground, we'll have a similar process check to air. In fact, we can just kind of copy this bit here. State process from air into ground. Gonna paste that in there, and we're gonna check if the character's not on the floor. Then we want the next state to be the air state. And yeah, that's pretty much it. So let's hit play, and we should start in the air state because our character isn't in the ground. If we walk off the cliff, we are in the air state, and we can do our double jump, but we can't do two jumps. Okay, so that's pretty much, logically speaking, everything we needed to do to recreate our original player logic into our character using a custom state machine. A couple small things I do see. First off, when we're doing the landing, the animation frames are playing kind of at a weird offset, so we'll fix that real quick. And then we can also clean up our player script before we end the video. So inside of player, let's remove everything we don't need here. So was in air is something we're not using. Animation lock and has double jumped, we're removing those as well. So let's clean up things and just remove extra lines. So for physics process, we're still adding the gravity from within the player script, but was in air is not a thing here. And we're also not going to do has double jumped, was in air, landing, or was in air. All of that has basically been moved to our ground, air, and landing state logic. And if we scroll down to the bottom, we can remove land and this callback from animation finished as well. So that basically leaves us with just ready physics process, update animation, and update facing direction here. And this update animation, I should really say update animation parameters. So this is just updating the stuff in the animation tree, which is just more convenient if we update it inside of the player script, since the player script is handling the input. So let's do update animation parameters and paste that in there right here. So we're still moving and sliding. We're updating the tree, the animation tree, and we're updating our facing direction with the sprite. Since we've done everything, we can remove the animated sprite node. Let's get rid of that. Delete the node for right now. And let's click on AnimationPlayer and kind of see what's going on with the offset of our sprite animation frames. So right here, we can see the jump end animation. Let's take a look at jump start. Okay, that equals, but run actually seems to be kind of off here. So if I recall, all you need to do for that is to go to Sprite 2D and turn off centering. And that's going to move our sprite down here to the left, but it's going to actually make their positions and all the frames sync up. So now we just need to move our character back to the center. So let's go to transform. And I think this is like 64 by 64. So we need to take the transform and do -32. And then on the position Y, we'll do -32 as well. Save it. And if we go to test level, then we should be able to hit play and check our animations. So we got to work on the offset because the character is standing at the wrong spot, but the landing now actually matches where the character was standing there. So it's just a matter of getting the collision shape to match the player now. So let's take the collision shape 2D and move it down to the character's feet. So right there should be correct. Let's hit play, go into the game mode. So our feet are touching the ground. We can jump, double jump, we can land, and everything's occurring at the correct spot. So that's pretty much it for creating a logic state machine for your platformer character inside of Godot. I know this was a pretty intense tutorial, but as you add in other states like attack states, maybe your character can do a roll, a wall climbing, wall jump, aerial strikes, ranged attacks. When you get to that level of complexity, I think it's going to pay off. So if this tutorial was helpful, thank you for watching. And of course, you can find the finished project in the description. So in the next part, we're going to do attacks and enemies, which was the original name of this part 2 project, but that's going to be part 3 now, obviously. But yeah, hopefully you guys are learning a lot. Hopefully everything makes sense. So thanks for watching to the end, and hopefully I'll see you in my future Godot content.